In this video, we're going to talk about how to solve probability density functions. So we're given f of x, which is 0.048x times 5 minus x. Now, if f is a probability density function, it has to be equal to or less than 0. So it can't be negative. So notice that when x is 0, the function will be equal to 0, and also when x is 5. So x has to be between 0 and 5. If x is 6, 5 minus 6 will give us a negative result. And if x is negative 1, this will give us a negative result. So x has to be between 0 and 5. Now, how can we verify that f is a probability density function? The integral from negative infinity to infinity of any probability density function, by definition, has to equal 1. And since x has to be between 0 and 5, the integral from 0 to 5 of f of x dx must also equal to 1. So this is what we need to verify. So let's integrate 0.048x 5 minus x dx from 0 to 5. And let's see if it's equal to 1. So the first thing I'm going to do is I'm going to move this constant to the front. And then I'm going to distribute x to 5 minus x. So it's going to be 5x minus x squared. Now the antiderivative of 5x, that's going to be 5x squared over 2, and the antiderivative of x squared is x cubed over 3. So now let's plug in 5. So 5 squared is 25 times 5, that's 125 over 2, and then 5 to the third is 125, but this is going to be over 3. And if we plug in 0, x squared and x cubed, they're both 0. So let's get common denominators. So 125 over 2, I'm going to multiply it by 3 over 3. And 125 over 3, I'm going to multiply it by 2 over 2. So 125 times 3, that's going to be 375. 125 times 2 is 250. And 375 minus 250 is 125. So this is going to be 125 over 6. 0.048 times 125, that's equal to 6. And 6 divided by 6 is 1. So therefore, f is indeed a probability density function. Now let's move on to part B. What is the probability that x is greater than 4? So to find a probability that x is between a and b, we need to evaluate the definite integral from a to b of f of x dx. So to calculate the probability that x is greater than 4, which means that it's between 4 and 5, we need to calculate the definite integral from 4 to 5 of 0.048x times 5 minus x dx. So at this point, I'm going to just use a calculator to get the answer. You know how to evaluate the definite integral. And so you should get 0.104. So as a percentage, if you multiply this by 100, there's a 10.4% chance that x is between 4 and 5, or that x is greater than 4. So now what about C? What is the probability that x is between 1 and 3? So this is just going to be the definite integral from 1 to 3 of the function. And so let's use the calculator to get that answer as well. And so this is going to be 0.544, which represents a 54.4% chance that x is between 1 and 3. Now let's work on another problem. The average wait-in time for a customer at a restaurant is 5 minutes. Using an exponential density function, find the probability that a customer has to wait more than 7 minutes. So to find this function, it's going to be 0 when t is less than 0. You can't wait for less than 0 minutes. And then when t is greater than or equal to 0, we have this exponential function. It's 1 over the mean times e raised to the negative t divided by the mean. And the mean represents the average waiting time, which is 5 minutes. So f of t is going to be 1 over 5 e to the negative t over 5 when t is equal to or greater than 0. So this is the portion of the function that we're going to focus on. So how can we use that to find a probability that the customer has to wait more than 7 minutes? So we want to find a probability that t is greater than 7. So we need to find the definite integral from 7 to infinity of f of t dt, or 1 over 5 e to the negative t over 5 dt. So this is the integral that we need to evaluate. So let's find the antiderivative of e to the negative t over 5. So it's going to be e to the negative t over 5 divided by the derivative of negative t over 5, which is negative 1 over 5. We're going to evaluate this from 7 to infinity. So this is going to be, well, first we can cancel 1 over 5. And so this simplifies to negative e to the negative t over 5 from 7 to infinity. Now we have an improper integral, so we need to express this as a limit. So this is going to be the limit as x approaches infinity, negative e, negative t over 5 from 7 to x. So if we plug in x, it's going to be the limit as x approaches infinity for negative e, negative x over 5. And then we need to plug in 7, so minus negative e to the negative 7 over 5. Now, e to the negative infinity, that's basically 1 over e to the infinity. And since it's bottom heavy, it's going to be 0. So this entire limit is equal to 0. And then these two negative signs will cancel. So it's going to be plus e to the negative 7 over 5, which is 1 over e to the 7 over 5. So at this point, we need to use a calculator. And so you should get 0.2466. So there's a 24.66 chance that the customer has to wait more than 7 minutes to be served food. Now let's move on to part B. Find a probability that a customer will be served within the first 3 minutes. So we need to find a probability that t is between 0 and 3. So we need to find the definite integral from 0 to 3 of this function. And so that's going to be 1 over 5 e to the negative t over 5. So let's find the antiderivative just like before. So we're going to divide this by negative 1 over 5 and then evaluate it from 0 to 3. And so this is negative e to the negative t over 5, 0 to 3. So let's plug in 3. It's going to be negative e to the negative 3 over 5. And then let's plug in 0. So negative e to the 0 power. E to the 0 is 1, and these two negative signs will cancel. So we have negative e to the negative 3 over 5 plus 1. Or you could say 1 minus e to the negative 3 over 5. And so this is equal to 0.4512. So there's a 45.12% chance that the customer will be served within the first 3 minutes of requesting their order. And so that's it for this video. So now you know how to answer some basic questions with probability density functions and even exponential density functions as well.